Good evening, everyone. Welcome to day two of our 15 days free training program on Python for AI. Yesterday, we started understanding the basics of Python. Let's just summarize it. So, yesterday, we've learned about Introduction to Python. So, in that, we've learned that Python is a high level interpreted programming language used for web development, automation, data analysis, artificial intelligence, and software development. It is maintained by Python Software Foundation. To, sim- to simply put it, Python is a programming language that allows us to write instructions in an easy and readable format. Secondly, the history and evolution of Python. So foundational idea was in 1980s and implementation of Python started in 1989. And the first release of Python was in 1991. And the creator of Python is Guido van Rossum. And it was developed at CWI Institute in Netherlands, and it was inspired from ABC language. The official website of Python is www.python.org. And then we have learned about the versions of Python. So there are three versions of Python, namely the first one, 1.x, and the second version and third version. The first version was released in 1991, and the basic features were introduced in the first version. And then it was discontinued in the year 2000. And then the second version was released in 2000, and it was widely used in industries. And it was discontinued in the year 2020. And then the third version was released in 2008, and this had cleaner syntax and better memory management and Unicode support. And also, this third version is being currently actively developed. And we should be using the third version for any kind of software development. And this third version is not backward compatible with 2.x, that is the second version. The latest stable version is 3.14.3. And then we've learned about the key features of Python. So Python provides us 11 to 12 powerful features, which makes it widely adopted. And it is easy to use and powerful. So the features are it provides a simple and easy syntax, it is freeware and open source, and it is platform independent. And Python is dynamically typed language. It is also portable and it is an interpreted language. And then it is a high level language. It is also robust due to its exception handling mechanism. And then the Python is extensible and it is also embedded. So extensible and embedded means it can use other languages services and also it can give other languages its services. So other languages can use Python services as well. And then it will support third-party libraries and also it supports procedural and object-oriented programming. And then we learned about the applications of Python. So Python is used in a lot of domains like web development and artificial intelligence and machine learning and also data analysis or data analytics and also desktop applications. And also it is used in automation, image processing, or text processing. And it is also used in IoT applications. It is also used in natural language processing. Then we've learned about the popular third-party libraries which Python uses. They are NumPy, Pandas, Matplotlib, Seaborn, scikit-learn, and TensorFlow, Keras. So these are all like the libraries which are used in ML, that is machine learning, deep learning, and also we use these in data science. So don't worry, we'll learn about these in detail later on. And then we've learned about the Python literals. So literals are fixed values which are used in a program. So without data or your fixed values which you give it to your program, the programs cannot run. So there are four types of literals, which are int literals, float literals, string literals, Boolean literals. So all these literals are stored in memory as objects. So inside of objects, your values will be stored. And then to identify these values with distinct names, so that is called as identifiers. So identifiers are like the names given to your memory locations where your values are stored. So variables are nothing but the identifiers whose values change during execution. So variables store the references to your objects which store your values. So variables or identifiers are like the names which will point to the objects which store your values. And then we've learned about the rules of writing variables. So mainly we need to write variables in a combination of alphabets, digits, and also we can use an underscore, which is a special symbol. And your variables must start with a letter, that is lowercase or uppercase letter, or it can start with an underscore. And it cannot start with any of the digits from 0 to 9. And there should not be any spaces between your variable names, like total salary, let's say. So this space, it should not be there, and we should not have any special characters like dollar or percentile or asterisk or etc. And our variables are also case sensitive. So if you give all lowercase letters or all uppercase letters, or if you give mixed case letters, these are all different and they are stored in different memory locations. And also your keywords like if, else, for, while. So these have some specific functionalities. So these are some keywords in Python, and these cannot be used as variable names. And also we've learned about the assignment in variables. So we can directly assign a variable that is equals to a value. So we can use assignment operator, which is equal to, and we can store our values. So this 10 will be assigned to X. That is your variable. This is your data or your literal. In this way, you can do a single line assignment, and you can also do multiple assignment. So You can do it in a single line by doing A comma B comma C equals 10 comma 20 comma 30. So what happens here is 10 will be given to A and 20 will be given to B and then 30 will be given to C. So the number of variables should be equal to number of values here such that it can be stored in a respective manner. So 10 will be given. So the first value will be given to the first variable in the code. And then the second value will be given to the second variable. And then the third value to the third variable. In this way, you can do the multiple assignment. So this is what we learned yesterday. Let's move on. So today we are going to learn about something which is extremely important, that is data types in Python. So before storing anything in a program, we must ask one question. So what type of data we are storing? And if we don't understand the data types, programming becomes very confusing. So if we understand them clearly, programming is very easy for us. So all of you, please listen carefully. So what are data types? Firstly, let me ask you something. If I give you a cupboard, will you mix the clothes, food, and books together? Will you mix all the different kinds of things together? You won't, right? So similarly, in programming, different kinds of data requires different storage types. So these storage types or your data types, these will define the type of value a variable can hold. So the purpose of data types is telling you the type of value your variable can hold and to allocate sufficient amount of memory space in your main memory of the computer. So data types will give you the type of value and it also allocates the sufficient amount of memory in your main memory. And also it will prevent errors during the execution. For example, let's say a variable called A and we are giving it a value of 10. So this is an integer type, right? So this is the number. So our A will be an int type of data. In the same way, if you give some number with decimal points, this is a float type. And similar way, if I'll take C, some text I will be giving. So this is a string type. So here A will be an integer data type and B will be a float data type of value and C will be a string. So Python automatically understands what kind of data we are storing in our variables. So that is why it is called dynamically typed variable language. So Python is called dynamically typed because it will automatically understand what kind of data we are storing in the particular variable. Unlike C or C++, they are static typed languages. Now, let us know about the data types. Python has 14 built-in data types and they are classified into 6 types or categories mainly. The first category is fundamental category data type. This consists of int values, float values, Boolean values, and complex type of values. And then secondly, we have sequence category data types. In that, we have string or str and bytes, and then byte array, and then range. And in list category data types, we have list and tuple. And then the fourth one is set category data types. So in this, we have a set or a frozen set. And in dict category data types, we have dict, or which is a dictionary. And then we have the sixth one is none type category data type. It has only one value, which is the none value. Now let us move on. So now we're going to learn about fundamental category data types. So these are called fundamental because they store only a single value. So the main purpose of a fundamental category data type is to store a single value. In Python programming, we have four types of fundamental category data types. So the first one is int, and second one is float, third is bool, and then complex. So small examples are int, that is integer values. They can be 10 or -25 or 0. Just the integer values are int type. And when it comes to float, these are some values with decimal points within it, like 3.14. So we have a point and then some values after it. So this is the decimal part. If your numbers have some decimal parts, they are float type, or 2.5. These are all float type. And when it comes to Boolean type, it has values that is true and false. And when it comes to complex data type, we have real plus imaginary parts in it. We'll learn about it in depth today. Now, moving on. Firstly, integer means whole numbers without decimal values. So int is one of the predefined class, which is treated as fundamental data type. So int values are just the whole numbers without any decimal values. The purpose of int data type is to store integral values or integers and whole numbers, and also the integer data, so that the data without decimal values. So in int data type, we can also store different types of values like decimal numbers, binary numbers, octal numbers, and hexadecimal numbers. So these four are the four number systems. So first, before moving on to number systems, let's know about the int function. So the purpose of int function is to convert a value into an integer. So even if we have any kind of value, if we put int of that variable or the value, this will be converted into an integer. So the syntax of int function is int value comma base. So here the value can be a number or a string in which you have your value. So the values doesn't have to always be strings, but if you are using your base parameter, it must be a string. So what is base parameter here? So the base parameter is the base from which you are converting. So that can be 2, 8, 10, or 16 values. So we'll know about these number systems or the base values right now. So you can use this int function in this way. So int of, let's say, some float value with a decimal part. So this will be giving us the result 10. And then int of 25, let's say. So this is a string, right? In that string, we have some number. So the output would be 25 without any string values. And then we can also give some binary number in a string. And we have talked about base, right? So for this, we need to give 2. For the binary values, we need to give 2. So from which base you're converting into integer, you should be giving here. So that would be 5. So let's clearly understand this. It removes your decimal parts, but it does not round up. It doesn't round off your values. It will just remove the decimal part and will give the integer part. And it will convert the numerical strings. So the strings in which we have some number or numerical values, it will convert that into numbers. And it will also support your base conversion. But if you give int of, let's say, some text hello, this will give error because your text or hello is not numeric. So this will be giving error there. Now let's move on to the number systems in int. So int consists of 4 number systems. They are decimal number system, binary number system, octal number system, and hexadecimal number system. So in decimal number system, we have total 10 digits. So that is from 0 to 9. So 0 to 9, we have the digits in decimal number system. And the base of any decimal number system is 10. So if you want to write some number, let's say 3 here. So the base of this is 10. So this is decimal number system. And then moving on to binary number system. So this binary number system, the total number of digits in this system are 2, that is 0 and 1. So we have only 0 and 1 in this number system. And the base of this number system is 2. So let's say we have some binary value and this is base 2. So this is binary. And then coming into octal number system. So the digits in octal number system are 0, 1, 2, 3, 4, 5, 6, 7. So we have only 8 number of digits from 0 to 7. And the base of octal number system is 8. So it will be written as in this way. So let's take some number that base is 8. So this is octal. And then we have hexadecimal number system. The digits in hexadecimal number system are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it will from 10 to 15, it will be given in alphabets. A, B, C, D, E, F. So A will be, the 10 will be written as A, the 11 value will be written as B, and then 12 will be written as C, and then 13 will be written as D, and 14 will be written as E, and 15 will be written as F. So you can write lowercase letters or uppercase letters also. So in octal number system, anywhere if we get 8 or 9 digits, that is wrong. So we'll get some error there. So in octal number system, there is no values of 8 and 9 digits. So in octal system, if we write, let's say 28, so this is wrong. So it's error. So we won't have the 8 and 9 digits in octal number system. Now, let us learn about the conversion from decimal number systems to binary and binary to decimal. So let's take 13 example now. So I want to convert 13, which is in decimal, to binary. So I want to convert the number 13 from decimal to binary. So what I have to do is I have to divide it with the base of the number system which I want to convert it into. So the base of binary number system is 2, right? So I'll take 2 and I'll divide with 13. So 2, 6, 12. So the remainder here will be 1, right? That will be writing as dash 1. And then I'll keep on dividing it with 2 till I get 0 at the end. So 2, 3 is a 6, and the remainder will be 0 here because 2 will divide your 6 with 3 exactly, right? So we won't get any remainder. That is, we'll get the remainder 0. And then 2 will be dividing this 3 value, and then 2 ones are 2. So 3 minus 2 is 1, right? So your remainder will be 1. So you'll write dash 1 here, the remainder. And then you'll again, to make sure, you'll divide it with 2 again. So 1 is not like divisible with 2, right? So 2 zeros are 0 you'll be writing. So 0 here. So 1 minus 0 will be 1 only, right? So your remainder will be 1. So here what we did is we'll just divide our number, which is in decimal number system, with 2 because we want to convert it into binary, right? So let me make sure to write it. So decimal to binary. So I want to convert this decimal number 13 to binary number system. So its base is 2. So you should divide with 2. So 2, 6 are 12. And the remainder when you subtract 13 and 12 will be 1. So you should write dash 1. And you should keep on dividing with 2 till you get 0 here. So 2, 6. So 2 3s are 6. So it is exactly divisible. So the remainder would be 0 here. And then you'll divide 3 with 2. 2 ones are 2. And the remainder would be 1. So you'll write that 1 here, dash 1. And then you'll divide 2 zeros are 0. And then 1 minus 0 is 1. So the remainder here will be 1. So from bottom to up, you'll take the numbers. So you'll take the remainder numbers from bottom to up, you'll be taking it. So that is written as 1011. So this is the binary equivalent of 13, which is the decimal number. And then, so you can see the same way I've done. 2 will keep on dividing your numbers till you get a 0, and then it will take from bottom to top. So 1101 is the binary equivalent of 13. So if I want to convert some binary number again to decimal number system, let's take the example of the same one, 1101. So now what I want to do, I want to convert binary numbers to decimal numbers. So binary means our base value is 2, and decimal means our base value will be 10. Right. So we are taking the example of 1101. So from this binary, I want to convert it into decimal number. So what I have to do is first we need to take the number neatly, and then I have to multiply these values with 2 per n values from right to left. So basically it will start with 2 power 0, and then 2 power 1, 2 power 2, and then 2 power 3. So what we should do here is we need to multiply these numbers each And then we should add them. So we should keep adding these numbers. So to neatly write it, just a second. So what we should do is, firstly, we have 2 power 3 into 1. So 2 power 3 into 1 plus this one, 2 power 2 into 1 plus 2 power 1 into 0. 2 power 1 into 0 plus 2 power 0 into 1. 2 power 0 into 1. So here the values are 2 power 3, which is 2 into 2 into 2. That is 8. 8 into 1 is 8 plus 2 power 2, that is 4. And then 2 power 1, that is 2 itself. Sorry, 2 power 1, which is 2 into 0. So that will be 0 plus 2 power 0, this is 1. And 1 into 1 will be 1. So 8 plus 4 plus 1. That will be your 13. 8 plus 4 is 12. 12 plus 1 is 13. So now the equivalent, the decimal equivalent of the binary number 1101 is 13. So if you want to convert decimal to binary, you need to divide your decimal value with 2 till you get 0 in the divisor place. And you should take your reminders from top to bottom. But if you want to convert your binary values into decimal values, what you should do is you should take the binary values and then from right to left, you should take 2 power n values from where n will be 0 to how many values you want n. So it will start from 0, 2 power 0, and then 2 power 1, 2 power 2, 2 power 3. So you will multiply each value as a pair and then you will be adding these values. So in that way, you can get it. So to remember, if you want like 4 bits, 8421 will be the values. So basically 2 power 0, which is 1, and 2 power 1 is 2, and 2 power 2 is 4, and 2 power 3 is 8. So a simple trick is that we can just remember 8421 for now, for the 4 bits. And if I want 13, let's say. So what we can do is, in these positions, we can put the combination of, let's see the combination of numbers which we can get 13. So I can add 8 plus 4 plus 1 and I'll get 8, 9, 10, 11, 12 with 4. So I'll get 12 and then 1 will be adding it to it and then we'll get 13, right? So this is the combination with which I can get 13. So in place of these bits, we can keep ones and in the remaining bits, we can keep 0. So this is the easy way you can get a binary value. So let's say instead of 13, let's do 10. Okay. So with what combination do you think we'll get 10? We can add 8 and 2, right? 8 plus 2 is 10. So in place of 8, I can keep 1 and place of 2, I can keep 1 and then 0. So this is the binary equivalent of 10, which is a decimal number. So this is the equivalent. So in that way, you can get the binary equivalent of any number. If I want, let's say 17. So we'll move on to the 6, which is 2 power 4 also. So the 2 power 4 is 16 value. You can take 5 bits number because it is a big number, right? It's 17. So I want to convert this into binary, let's say. So what should I do then? In place of the 16 number bit, I can keep 1. And if I add 16 with 1, that will be 17, right? So in place of that, I can keep 1 and remaining all will be zeros. So this is the first bit, and this is the second bit, and third bit, fourth bit, and fifth bit. So this is the 5 bits data. So I want 17. So I can give 16 plus 1. So in place of this bit, I can keep 1. And in place of this bit, I can keep 1 and other all 0. So if you do 1 into 2 power 0 and this 1 into 2 power 4. So here it will be 2 power 1, 2 power 2. Let me just clear it. Okay. This is 2 power 1 bit position. This is 2 power 2 and 2 power 3. So even if you go with the traditional method, as these are zeros, these values will be zeros only, right? So you don't need to consider this. And this is 2 power 4 into 1 plus 2 power 0 into 1. That is 16 plus 2 power 0 is 1, 1 into 1 is 1. So at the end you will get 17. So in this way, easily you can get binary values of any numbers. And then now let us know how we can convert any octal number. So before this, let us know the octal and hexadecimal also. First, let us know how we can convert a decimal number into octal number. So we'll take the example 23. So I want to convert a decimal number into octal number. So decimal base is 10 and octal base is 8. So we want to convert, let's say 23 from the decimal number system to the octal number system. So what you have to do when you want to convert decimal to any number system is you need to divide with 8, right? So you'll take 23 and you will divide with 8. So 8 3 is a 24, right? So it will exceed. So 8 2s are 16. And the remainder for it will be 7, right? So we should write dash 7, the remainder. And then we need to divide again. So 2 is not exactly divisible by 8. So 8 zeros are 0. So 2 minus 0 is 2. So dash 2. So these are the reminders for this divisors. And then we got 0 here. So from the top, from the bottom, you should take to the top. So 2, 7. So the value is 27. So 23's equivalent in octal number system is 27. So when we convert 23 from decimal to octal, that will be a 27 value. So now let's see if we want to convert octal number to decimal number. So what we should do? Let's take the same number example and I want to convert it into decimal, let's say. So I should take the digits 2, 7 and I should start with 8 power n values. So 8 power 0 will start with 0 till n. So 8 power 0 and then 8 power 1. I need to multiply these pairs and I need to add them at the end. So to simplify, so 8 power 1 into 2. 8 power 1 into 2 plus 8 power 0 into 7. 8 power 0 into 7. Okay, so 8 power 1 is 8 into 2 plus 8 power 0 is 1 into 7. So 8 2s are 16 plus 1 7s is 7. So 16 plus 7 will be 23. So this is the decimal equivalent of 27, which is an octal number system. So when we convert 27 from octal to decimal, that will be 23. Next, moving on. So now we are converting decimal number systems to hexadecimal and hexadecimal to decimal back. So here example is 172. Let's just do it ourselves. So now I'm converting decimal number system, which is of base 10, to hexadecimal number system, which is base 16. So now the example is 172 and I want to convert this to hexadecimal. So what should I do? I should be dividing the 172 or the decimal number with the base of the hexadecimal number system, which is 16. So divide with this 16. So 16, the nearest one would be 16 tens of 16. So basically, if you do it this way, 16 ones are 16. So if you want to do it totally, 16 tens are 160. So 16 tens are 160. So the remainder would be 12, right? So dash 12 you'll be writing. And then, so this is still not 0. So I should divide with 0. So 16 zeros are 0. So 10 minus 0 will be 10 only. So the remainder would be 10. So we should take the values from bottom to top. So the values will be 10 and 12. So as you learned in hexadecimal, so the numbers will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when it comes to 10, that will be A, 11 will be B, 12 will be C, 13 will be D, 14 will be E, and 15 will be F. Right. So in this way we can write. So 10 here is A. So in place of 10, we'll be writing A. And in place of 12, we'll be writing C. So the hexadecimal equivalent of this decimal number 172 is AC. So if we convert it, we'll get this way. Now I want to convert the same hexadecimal value back to the decimal values. So the AC, which is in hexadecimal, I want to convert it into decimal value. So what should I be doing? I should take A and C, and as we learned, A's equivalent is 10, B 11, C 12, D 13, E 14, and F 15, right? So in place of A, I should take 10, and then in place of C, I should take 12, and then I should multiply these values here with 16 power n, which is 16 power 0, which should start with 16 power 0, and then move on. 16 power 1. I need to multiply these numbers and add these results. So basically, 16 power 1 into 10 plus 16 power 0 into 12. So that will be equal to 16 into 10 plus 16 power 0 will be 1 into 12. So that will be 160. So 16 into 10 is 160 and 12 into 1 is 12. So the addition would be 172. So the decimal equivalent of your hexadecimal number AC is 172. So now we will learn some deeper conversions. So now we'll learn how we can convert octal numbers into binary and hexadecimal into binary, and also binary to octal, hexadecimal to octal, and then binary to hexadecimal and octal to hexadecimal. We just learned how we can convert decimal to on any other number system and that number system to decimal, right? So we will learn in between the conversions also. Now let's learn about binary. Yeah. Now let's learn binary number system conversion. So we've learned about the decimal to binary, right? So what we'll do is we'll just divide with 2 till we get 0 as the divisor, and you'll take the reminders from top to bottom. And if you want to convert octal number systems, that is base 8, to binary number systems, so base 2. So let's take an example of 25. Okay. So now how I can convert this octal number into a binary number? So first what we should do is we should take 2 and 5. Okay. 2 and 5. And I need to convert them into 3 bits. So basically octal number system is considered into 3 bits because it is represented from 0 to 7 numbers, right? So if you take, so the number of digits is 8. So 2 power 3 is 8, right? So you will be considering, if you take the basic idea, the 3. So it is represented with the 3 bits. Internally, what the working is, if you take the combination of 3 bits, all the combinations, so 000 or 001, 010, 011, or 100, 101, 110, and then 111. So these are all the combinations we can get with 3 bits with zeros and ones. Okay. So the first combination will be a 0. And then here, this is 2 power 0, so 1. So this is the combination of 2. And then if we go on, the 111 combination is 7. Because I've said you the code, right? 8421. If you take this, so here 1, 1, 1. In this bit, there is no number. So 4 plus 2 plus 1.
So here the number will be 4 plus 2 plus 1. So that is 4 plus 2, 6, 6 plus 1, 7. So this is 111 is the equivalent of 7. Okay. So these are the combinations from 0 to 7. These are the different combinations I can get with the 3 bits. So I should write now. Okay, let's take the 3 bits for 2. That is 0, 1, 0, 0, 1, and 0. And for 5, I need to take the 3-bit combination which is 1, 0, 1. Now, I should take all this combination. So, for the 2 is 0, 1, 0. And for 5, it is 1, 0, 1. So, this is the binary representation of 25. So, what you should do is you should take your single digits. So, as it's 25, so you should take 2. And then for 5, so you should convert 3-bit binary values. So 2 is written as 0, 1, 0 because 0, 1, 0, right? So 1, 2, 4, let's say. As we know, 2 power 0, 2 power 1, 2 power 2, right? So here it is only 1. So 2 into 1 will be 2. So this is the binary equivalent of 2, that is 0, 1, 0. And this is 5, 1, 0, 1. So 4 plus 1 is 5. So if you take in that way, 4 plus 1 is 5. So this is a 5 equivalent. What you should do is you should combine these both combinations and you should write this is the 2 binary equivalent and this is a 5 binary equivalent. So this is 0, 1, 0, 1, 0, 1. This is the binary equivalent of the octal number 25. Now let's erase this. Okay, let's now learn about the third conversion, that is from hexadecimal base 16 to binary. Let's just clear this part. So hexadecimal values are basically represented with 4 bits. So octal is 3 bits, right? Hexadecimal is 4 bits of numbers, because as you know, the base 16 is 2 power 4, right? So it will be written with 4 bits. If you go deeper, if you take 4 bits and combinations of zeros, so it will go from 000, it starts with 1, 0, and then you'll go with 0001 and 0010, and so on. All the combinations you'll write till 1111, right? So this combination is 15. As you know, the hexadecimal number system has digits from 0 to 15, right? So that is why we have 4-bit representation for 16. That is the hexadecimal number system. Okay. So I want to convert a hexadecimal number to binary number, that is 2. So the hexadecimal, we can take a value of AF. Okay. So as we know, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay. So what you should do is you should take A and F. So A is 10 and F is 15. So now we need to convert these decimal numbers into 4-bit binary numbers. So I want 4 bits of data which are equivalent to these numbers. So as we know, our code 8421, we'll take that. So I want 10. So how can I get the 10 combination? I'll do 8 plus 2. So 8 plus 2 is 10, right? In that place, I'll keep ones, and in the other places, I'll keep 0. So the equivalent will be 1010. And then I want 15. We'll use the same trick. So these are the numbers or the bits values here. And I want 15. So I want 15. How can I get it? So 8 plus 4, which is 12. 12 plus 2 is 14. And 14 plus 1 is 15. So each and every bit should be 1. So 15 equivalent is 1111. So now I got the binary equivalents of these numbers, right? So what I'll do is I'll just combine all of them. So 1010 from 10 and 1111 from 15. Okay. So this is the 10 equivalent and this is the 15 equivalent. Will combine it and write it as a binary number. So the binary equivalent of the hexadecimal number AF is 10101111. So in this way, you can convert a decimal number to binary, or octal number to binary, or hexadecimal number to binary. And then we'll move on. Let's learn about how we can convert any number system to octal number system. Firstly, as we've learned, the decimal number system, which is 10, to octal number system 8. So what we should do is we should divide your decimal number with 8 till you get the divisor as 0, and you should take the reminders from top to bottom, and that will be your octal number system. So I want to convert the binary number system to octal number system now. So binary to octal, that is 8. Okay. So let's take a binary value 111001. Okay. That's a binary number. I want to convert it into octal number. So what I have to do is, I should take the binary digits. And we have got to know, right, octal is represented with 3 bits. So that is why from right to left, you should divide these bits of numbers into three parts, like 3 digits in one part and then other 3 in other part. So you should divide it into groups of 3. So now the equivalent of 0, 0, 1, how we can find in this way, 4, 2, 1. So as there are only 3 bits, so this is the equivalent of 1. 0, 0, 1 is the equivalent of 1. And then 1, 1, 1. How we can find it? 4, 2, 1. So 4 into 1 plus 2 into 1 plus 1 into 1. That will be 4 plus 2 plus 1. That is 7. Okay. So in this way, we can get the octal equivalent of some binary number. So 111001, when we want to write it as octal number, that is 71. 71. And then I want to find, so now I want to find hexadecimal number system to octal number system. Okay. So how I can find it? Let's take a hexadecimal number which is 1BC. So from 16, I want to convert it into octal number system. So what I should do is I should take 1, B, C separately. As you know, A is 10 and B is 11 and C is 13. Sorry, C is 12 and D is 13 and so on, right? So we just need B and C right now. So 1, we should represent in 4 bits here, because as we learned, hexadecimal is represented in 4 bits, right? So 1 can be written as, if you take the 8421 rule. So I just want 1. So in place of here, this bit I'll keep 1 and other all, that is 0. So 0001 is the equivalent, binary equivalent to 1. Okay. Then B. So B means 11, right? So 11 equivalent I want to find. So how I can find? The combination I should find. So I can add 8 plus 2 plus 1. So 8 plus 2 is 10. 10 plus 1 is 11, right? So in place of that bits, I'll keep 1 and remaining I'll keep 0. So this is the binary equivalent of B, that is 11. So you can write it as 1011. And C, that is 12, right? So I can write 12. How can I write 12? I can get the combination of 8 and 4. So 8 plus 4 is 12. So in that bits places, I'll keep 1 and other all I'll keep 0. So the equivalent will be 1100. Now I need to combine this whole binary numbers 0001, 1011 and then 1100. So I got the binary equivalent. Now I want to get the octal, right? So in octal, it is represented with 3 bits, like I've told you, it is represented with 3 bits, right? So we should convert groups of 3 here. From right to left, you need to convert groups of 3. So this 0, 0, 1 is one group, and then 1, 1, 1 is one group, and then 0, 1, 1 will be a group, and then all 3 zeros. Let me neatly write it so there won't be any confusion. So 0, 0, 0, 1, 1, 0, 1, 1, and then 1, 1, 0, 0. So now I should divide it into groups of 3 from right to left. So this is group of 3, and then this is a group of 3, and this is the group of 3. So 0, 0, 0. That is just 0, right? And when it comes to 1, 1, 0. So this is 1, 2, 4. So that is equivalent of 4 plus 2. So here 1's right. 4 plus 2 is 6. So 1, 1, 0 is the equivalent of 6. And when it comes to 1, 1, 1, so 4, 2, 1 again. So we just use 3 bits here, right? So I've used 4 to 1. If I want 4 bits, I'll take the 8 also. If I want 5 bits, I'll take 16, 8, 4, 2, 1. Because 2 power 1 is 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, and 2 power 3 is 8, and 2 power 4 is 16. So in that way I'm using, so don't get confused. Okay, moving on to our topic. Yeah, 4, 2, 1. So 4 plus 2 plus 1, which is 7. And here again 4, 2, 1. So in place of this bit we have 1. So it is 4. So the hexadecimal number 1BC equivalent of that in octal is 674. So you can just ignore this 0. No worries. So the result will be 674. Now let us learn how we can convert any other number system to hexadecimal number system. We learned about decimal to hexa and hexa to decimal, right? Now we'll learn about other systems. So first, as we know, decimal to hexadecimal, we should divide with 16. And then if I want to convert a binary number of base 2 to hexadecimal number of base 16, so what I should do is, let's take a binary number 110, 110, 100. So I want to convert this binary number into a hexadecimal number. So as you know, hexadecimal number is represented with 4 bits of data, right? So you should group them into 4. So from right to left, I'll group the first 4. So right to left you should do is always, and this 0010 will be in the first group, and then the next 4 will be in the next group, and then we have only 1 here. So fill with zeros. How many left over? You need to fill with zeros. So it is only 1. So I filled with 3 zeros. So this is a group. So we have 3 groups here. So you need to find the decimal equivalent of these numbers, that is 8, 4, 2, 1. We are using our trick here. So in the place of the third bit we have 1, so that is 4. So this 0, 1, 0, 0 value is 4. And then the same one here, 8, 4, 2, 1. So 8 plus 2 plus 1, as we have ones in this bits place, 8 plus 2 plus 1, that is 11. Okay. And then here we have just 0001. So when it comes of 001 or 001, that's just 1, right? So 1, 11 in the hexadecimal, B means 11, A means 10, right? So B is 11. So 1B, 4. So 1B4 is the hexadecimal equivalent of the binary number 110, 110, 100. Okay. Now let's learn about the third one, octal. Base 8 to hexadecimal base 16. So how can we do this is, we can take some example 152. I want to convert this number into hexadecimal number. So what to do is, I should convert these individual numbers into first 3 bits. So we are converting octal, right? So first we should take 3 bits. So 1 can be written as 0, 0, 1, and 5 can be written as 0, 1, 1. just take your trick and just write 4 to 1. Keep it in mind. 4 to 1. So I can write 1 as 0, 0, 1 and 5 as 0, 1, 1 and then 2 as 0, 1, 0. Okay. Now you should combine all these numbers. 0, 0, 1, 0, 1, 1 and 0, 1, 0. Okay. Now hexadecimal is represented with 4 bits, I've told you, right? As we've done in all the previous examples. So what you should do is from right to left, you should divide them into groups of 4 again. So this 4 and this 4, and we have only 1 0 here. So just fill with other 3 zeros and this 4. Okay. So now 1 0 1 0 equivalent we should find. That is 8 4 2 1. So if you get 8 plus 2, that will be 10. So in hexadecimal, 10 means A, right? So in place of 10, I'll be writing A. And then here again 8 4. Okay, so 5 here is written as 1 0 1. Sorry, my bad. So 5 is 1 0 1. So here there will be 1 and here it is 0. So in this bunch 8 4 2 1. Okay. So you will be adding 4 plus 2. So that is 6. And here all zeros are there. So you don't need to consider it. You can consider it as 6. Oh, sorry, 0. And you will get the answer as 6A. Okay. 6A will be your answer. So 152 octal number equivalent is 6A in hexadecimal. So in this way, you can convert any number systems into decimal or binary or octal or hexadecimal. Now, let's look at the coding part. So coming to the fundamental category data types, firstly int. So here as you can see, A is equals to 19. So this 19 value will be given to A and A will be considered as an int data type. So let's just run our code. So A is equal to 19 is taken. And if I print our variable, as we learned yesterday, the print function. So instead of print, I should have my value or my variable name or any statement, right? Okay. So I'm trying to print A. That is, we got 19. So this type function is to know what data type our variable is there. So type of, if I give the variable that is A, which I have stored value 19. So what data type will get? Will get int. So as 19 is an int data type value, we'll be getting the type of A as int. And I've changed the value A to 999. So now I'll print A. So this value changed, right? So now the same A which used to point to 19 is now it is pointing to 999. So that is why our A is a variable which changes value during the execution. So now A is 999. If I print our A, that will be printed here. And now I want to know the type of A. So that will be int. So let's take a new variable. Let's say ABC equals to, let's give 2, 3, 4, 5. So now I'll run this such that that value will be assigned to ABC. Now I'll print the value. Print your variable name ABC. So if I print that value, so I'll get the value stored inside of ABC. And I want the data type of ABC now. So what I'll do, I'll take the type function with parenthesis, and inside of that parenthesis, I'll give the variable name. Now I will run this and I'll get int, because 2, 3, 4, 5 are numbers and integer values. So ABC variable is an int data type. And if we want the memory address at which our variable A is pointing, so to get that memory address, we should use the function id of A. So now A is pointing to 999, right? So the memory address of A is, so this is the memory address of variable A. Now if we want memory address where our ABC is stored, let's see id of parenthesis ABC. So that value will be this. So it's a long value. Memory addresses are always a long number of combinations of digits. And as we have learned the int function, so here this value is our value or the string. So basically, as we've given the base parameter, we have given this value in a string. So I want to convert the binary value, which is 101, to integer value, that is decimal, right? So I'll give base 2 because this is a binary number. I want to convert binary digit to decimal value. So what happens is this will run and our A consists of 5. So 101, as we have learned, I've told you the 3-bit trick, right? So 4, 2, 1, you can just have, okay, 4, 2, 1. So here it's 1 and in this place bit it's 1. So 4 plus 1 is 5. So you got 5. If I want, let's say, I'll take B. B equals to int of, let's give a hexadecimal value. Let's try octal now. So I'll give 23, comma, the base of octal is 8, right? So I've given 8 and I'll print B. Okay. So first run this and then this. So the octal equivalent is 19. And then if I continue, C equals to some int value of, let's say, AF. I want to convert this hexadecimal value into integer value. So I'll run this code. You can run as a batch or a single line also you can run it. So that will be our equivalent integer value. Then we'll move on to the binary number system. So the variable, if you want to give it as a binary value, what you should do is you should be using 0b, either the small b and then the binary data, or you can use 0 capital B and then the binary data. Okay. So here as you can see 0B1010, this is the binary data here, and we want to see this value. Let's see. Let's run this. A equals to, we gave some binary data. And if we print, so this binary equivalent here is 10. Because as you know, we'll take 1, 0, 1, 0. Okay. So 8, 4, 2, 1. So as we here have values here, 8 plus 2 is 10. So this equivalent is 10. Even if you give any variable as a binary or octal or hexadecimal, internally what Python does is it will store it as a decimal number itself. So that is why when I give a equal to some binary data, the a type is, so the a value is stored as decimal and the class is int. As you can see, the type of a is still stored as int. And then moving on, here we've given capital B 1 1 1 1. So 0 B and then you have your binary data. So this equivalent is the same thing you can use 8 4 2 and 1. So 1 1. So the value is 8 plus 4 plus 2 plus 1. That is 8 plus 4 12, 12 plus 2 14 plus 1 15. So this value equivalent is 15. So let's just see what it shows. So a equals to 0b 111. So internally it will store in decimal value. So a is given as 15 here. And the type will still remain int. If you see here in place of 0, we gave o. So this is a small o. But that is not valid. So this is given as not defined name error. You should only give 0 and then b. Either it can be lowercase b or uppercase b, and you should give your binary data. Internally, it will be converted into the default number system, which is decimal number system. And if you see here, we've had 0 and b. That's nice. And then we have 2 here. In place of the binary data, we have a digit 2. But in binary number system, we have only 2 digits, that is 0 and 1, right? So here there will be an error because of 2. If you run this, A, so the invalid digit 2 in binary literal. So we will get a syntax error because only 0 and 1 are the digits in binary number system. So you should only give in zeros and ones when you are working with binary data. Just a second, guys. And then we'll learn about the octal number system in Python. So this octal data must be preceded with either 0 small o or 0 capital O. So the syntax will be a variable name which is equal to 0 either small o or 0 capital O. And then we can have our octal data after this. So this octal data must be preceded with 0o, either smaller, lowercase or uppercase. So in this way, you can give your octal data. Here, for example, we've given 0 small o. And the octal value here is 13. As you know, the octal values are from 0 to 7, right? And 8 and 9 will not be there in octal values. So we've given 13. Okay, so a equal to 13. Internally, it will be converted into the default number system, which is decimal number system. right? So any binary data or octal data or hexadecimal data, it will be internally converted into decimal number system only, and it will be stored in that way. So A will be 11. So in decimal form, 13 is 11. And the class which is it stored is in int only. And here we have tried with 0 capital O, and the octal data is 17. And we'll run this. So this button here is used for running any selection or your current line, okay? So I'll run it, and this octal data 17, in our decimal number system, it is written as 15, and our class will be remained same. So as you can see here, I have given A equal to 682. But as we have learned, in octal number system, we'll only have digits from 0 to 7, right? 8 and 9 are not allowed in octal number system. So we'll get error here. When I try to run this, so invalid digit 8 in octal literal. So in octal number system, we cannot have the digit 8. So moving on to the hexadecimal number system. So this hexadecimal number system, in that the hexadecimal data must be preceded with 0x, either lowercase x or uppercase x. So the syntax is 0, and you should have your small x or 0 and then capital X. And then you should have your data, which is hexadecimal data. So your hexadecimal data must be preceded with 0, lowercase x or uppercase x. And then this data will be internally converted into decimal also. So here we have the octal data AC. Okay, now when I store this value, hexadecimal value into A, and I try to print it, and I'll get the type of it. So we've done this sum right in the explanation. So AC means 172 in decimal number system, and the class will be int only. And then secondly, B equals to 0x, and the hexadecimal value is BEE. So here, let's try doing. So hexadecimal to decimal, to convert it, what we'll do is, just give me a moment. So B in hexadecimal, A is 10 and B is 12. Sorry, 11. A is 10, B is 11. In the same way, C is 12, D is 13, and when you come to E, it's 14, right? So what you'll do is, you will take that numbers 11, 14, here to 14. And what you'll do to convert this hexadecimal number to decimal number is, you will multiply them with 8 power n's from 0 to n. So 8 power 0, 8 power 1 and 8 power 2. Just a second. 8 power 2. So here 8 power 2. So 8 into 8 is 64. 64 into 11, you will be getting 704. And then 8 into 14 is 112. And then 8 power 0 is 1. And then we'll add 14 to that. Let's just first run it. So 704 plus 112 plus 14. One second. So here your 0x BEE, when it is converted internally into a decimal number, sorry, hexadecimal number, right? My bad, guys. Sorry. That is why. So as here it is an hexadecimal number, we should multiply it with 16, right? 16 power 0, 16 power 1, and 16 power 2. There's a little issue with pen, so do not worry. Just try it on your notebooks. So 16 power 2, which is 16 into 16. So 16 into 16 is 256. And the B value is 11. So that will be 2816. And then 16 power 1, which is 16 into 14. So E value is 14, right? So 16 into 14 is 224. 224. And then 16 power 0 is 1. And 1 into 14 will be 14 only, right? So 2816 plus 224 plus 14 will be your value 3054. Okay, so that's your value. You can convert it that way. And then we will move on to the values. Here we have the hexadecimal data is FACE. So you can use uppercase letter or lowercase letter also, right? So you can use this way, and your hexadecimal values here is FACE. So you are giving it to C value and you want to print it. So if you convert this hexadecimal data into decimal data, that's value is 64206 and the class is int. And moving on, we have ACE and that value is 2766. Just convert these, try using the methods I've explained before and convert it, and you'll get the same values you have here. And if you, so the letters we have in our hexadecimal is from A to F only, right? So as they used R letter here, so that is not included in hexadecimal number system. So we'll be getting an error here. So let's just try running it. So it will give invalid hexadecimal letter. Even if I try some 0x other than A to F, let's see, STU. Well, still, obviously, STU are not the letters included in hexadecimal number system. So it is an invalid literal. So we'll be getting syntax error. And now let's try doing the base conversions. So we have three types of base conversion functions. The first one is bin or the binary function. This is used to convert any of the bases like the octal or hexadecimal or decimal into binary number systems. So how you can use this is you can take a variable name. Let's say I have taken here 15 value. So this is decimal number. And if you print it, so A is 15 only here. So for B, I'm assigning the bin function. So to use this function, I should have the bin of either your variable or your value. Let's just try coding. Here I've given the binary the conversion of A to B. So if I run this and run it, so this is the binary equivalent of 15. As you learned till now, 1111, that is your binary data here. And that is the equivalent of 15, right? So you can use it in this way. Or here we have octal data. So 0 it is used for octal number system, right? So the 14 is the octal data, and I want to convert this octal data into binary. So what I can do is I can assign the octal data to some variable A, and the binary of that A is given to B. So this value will be assigned to B, and if we print it, so this is the octal binary equivalent of the octal data 14. So instead of just assigning it, let's try A, okay? So I can just print directly the binary of A in this way. I don't need to like assign it to a variable. We can do this as well, or we can do this way as well. We'll get the same value. So this is the binary equivalent of the octal data 14. And then we are doing the hexadecimal data. So here the hexadecimal data is AC, right? So I'm assigning this hexadecimal data to A. And then I'm converting that A into binary using the bin function, and I'm assigning that to some variable B. Okay, and I want to print it. Let's just print it as a whole bunch. So AC hexadecimal data. So that is in binary form, it is 10101100. If you try doing the methods I've done before, you will be getting the same values. And here the octal data is F, and it must be preceded with the 0x, right? So octal data is F, and I want to convert this octal data into binary data. So what I have to do is I can use bin function again and do this. So F means, 15, right? So 15's equivalent is 1111 in binary. So that is how we got this. And then in the same way, we have oct function. This is used to convert any of the bases from binary or hexadecimal or decimal values into octal number system. That is to the base 8. So how you can use it is variable name will be equal to oct function of the decimal value or binary value or hexadecimal value. So what you should do is you can give A equals to some decimal value. Let's say I have taken 15 here. So we'll run it. And then I'm using oct function. Same like how we used bin function. I'm using oct function. And oct of A will be assigned to the LHS, that is B, that is your variable. And let's run it. So if you want to print B, that will be 17. So the decimal value 15. In case of hexadecimal, that is 17. In the same way, I want to convert this binary data 101011 into octal form. So I'll use octal of oct of parenthesis. Inside of that, I'll have the variable that is A here, and I will run it, and I'm assigning this oct of A to B. So B is the octal equivalent of the binary number A. So A is this, and B is the octal data. So 53 is the equivalent of this binary value. As you can see, how we did is, if I want to convert some binary value 101 and 011. So octal means I've told you, right? 3-bit representation. So we will group them into 3 parts. So this part is 4, 2, 1. So 4 plus 1, that is 5. And then when it comes here, this is the representation of 3, right? 2 plus 1, that is 3. So 53. So that is what you got here. This is the octal representation of the binary value you have. And then moving on, we have one more value. So this is the binary data 1111, and I want to convert this into oct value. So that is, so in decimal form, 1111 means 15. And if you convert that to octal, you'll have 17. And then this is the hexadecimal value f. F means also 15. And you want to convert it into oct. So the 17 you have. So same. So this is the binary form of 15, and this is f is the hexadecimal form of our decimal number 15. So when you convert both of them, you will get the same octal data, that is 17. And then moving on, we have hexadecimal value BEE. As you can see here, capital B and E and E. I want to assign this to a variable A, and then using oct function, I'll convert this variable A to octal number system, and I'll assign that to B variable. Okay, so the octal equivalent of BEE is 5756. Just note down these and try doing them in the methods I've told before and explained before, and you'll be getting these results. Also, do the hands-on, obviously, so you can learn better. And we will learn about the hex function here. So what hex function does is same like bin and oct. It will convert any base data like 2, that is binary, oct, and the decimal, to base 16, that is hexadecimal. It will convert any kind of any base data to hexadecimal number system data. So we have a equals to 10, which is a decimal value, and we are assigning that value to a. So let's just run it. And then I'm giving the hex of A. So the hexadecimal equivalent of A variable is assigned to B. And now we'll print B. So the hexadecimal equivalent is here A. As you know, 10 means A, capital or small. So 10 means A, right? So that we have A here. And then if I try giving A equals to 8, when we convert it into hexadecimal number system, till 0 to 9, the numbers are same, right? So 10 to 15, we'll get A to F letters. So we got the same 8 when we convert it into hexadecimal number system. So it is 8, and moving on. Here A equals to 0B111. So the binary this is the binary equivalent of 15. So when I try to convert it into hexadecimal number system, so that will be F. Okay, so that is the equivalent, and I'm converting octal number, that is 17, to hexadecimal number system. So that is also F, because this is the binary representation of the digit, so the number in decimals 15, and this is the octal representation of the decimal number 15. So in hexadecimal, 15 means F, right? So that is why you will get these. And then now let us know about float number system. So I just forgot to tell something. So as you can see here, the class is given as string, right? So when you use these hex or bin or oct functions, so bin or oct or hex functions, when you use it, these functions will return string values. So that is why you have class string here, and they won't return you integer values. So if you see, if I get this value 0 x f, so this value we got in string. So it is basically in this way. So this is not a integer value, right? Obviously, integers only have the numbers, but we have here alphabets. So this will return, these functions will return your value in the form of string and not integers. So now we'll move on to float now. So float data type can store numbers in scientific notations. And before that, float is a predefined class which is treated as fundamental data type. So to store any floating point or real constant values, so let's say some values like 3, 3.14. So to write, second, so to write 3.14. So this has decimal values, right? Here it has a decimal part. So this is a float value. So if you have floating point, which is the decimal value or the real constant values, so that is the float data type. So the purpose of float is to store a floating point values or real constant values. And then float data type will only allow the decimal number system, and it will not support any binary number system or octal number system or hexadecimal number system values. It will only support the decimal number systems. And float data type also supports to store scientific notation whose general format is mantissa e exponent. So that means the scientific notation mantissa e exponent means we have a value that is e in float. So it lowercase e or uppercase e. So what is the scientific notation? First, let's learn about that. So scientific notation is, it is a way to represent large numbers or very, very small numbers. So to represent very large numbers or very small numbers, you will be using scientific notations. So in general formula, it is mantissa into 10 power your exponent. So basically, if you write some variable x equals to 3.5, 3.5 into, sorry, 3.5 E4. So if you write 3.5 E4, this is the equivalent of 3.5 into 10 power 4. There's just a little issue with the pen, so do not worry. 10 power 4. So when you use E, it is like the 10 power something. So the value. So the before value into, when you use E and 4 or some number, 10 power E. If you use E2, it is 10 power 2. So the calculation will be 3.5 into 10,000. So 4 zeros will be there, right? In the 10 power 4. So that will be 3.5 into 10,000, which is 35,000.0. So the output will be in float value. And if you have very small number like 2.1 E 2.1 E minus 3, let's say. Okay, so this is a very small value because 2.1 E minus 3 means 10 to the power of minus 3. So 10 power minus 3 is 0.001. So E power 3 means 10 power 3, which is 0.001. So the value will be 0.0021. So the value will be 0.0021. So basically here E means like the 10 power. So mantissa means it's just a normal decimal number like 3.5 or 2.1 or 3, 2, 7, any number. Like the decimal number is called the mantissa here. And E means 10 power. And exponent means the power of 10. That can be 2 or minus 2 or minus 3 in this case. And so it is the normal decimal number E to the power. Maybe a negative or positive number. So in that way, we can write our float values, and Python stores it as a float value and not int value. So when you use E, it will be stored as float value. So the purpose of the float function is it will convert any decimal number to float value. So it can be used as float of value. So the syntax of float is float of value. And examples can be float of 10. So that will be converted to 10.0. If I give float of some decimal or integer value, the result will be 10.0. And if I give float of some string value which has a float number, we will get the float. So the characteristics of this float function is it will convert any int value to float value. And if it has some numeric strings also, that will be converted to float value. And it will also support the scientific notation which I've explained you, that is mantissa E exponent. And it only supports the decimal number system values and not binary or octal or other hexadecimal number systems. So let's look at the code right now. Let's move on to our spider environment. And here, so float. So as you can see here, I've given a equal to some float value as it has that decimal part. So this is a float value. When I assign this value to a and I'll print a, let's do it manually for once. So I'm printing a, so I'll get the value I have. And then if I want print of, I want the type of a. So what do you think we'll get the type of a? So we'll get class float. And if there is the decimal part, if you have too many number of zeros and at the end if we have one also, that will be considered as float only. So let's say I have 0 point so many zeros and 1. Then also your value will be considered as float only. So this is the scientific notation we've talked about. We will get the float value in the exponent function. So let's remove some zeros and try. So we'll get the float value. And if I also do a division of some numbers and I assign it to a variable a, and then also that a value internally, it will be the float value. And the class will be the float. But as we have learned, float will only support decimal number system. It will not support the hexadecimal or binary or octal, right? So these are invalid. So this is an invalid decimal literal because we got the syntax error. We've used binary number system. And if you go to the next example, here we have used hexadecimal number system, the F value, which is the 15 value. And also we have binary data. So this is some mixed kind of thing. So this is also not valid. So this is an invalid decimal literal. So it is not decimal, right? So this is invalid and we'll get a syntax error. And then moving on. So this is an octal data. As we have O here, this is the octal data and that is also not compatible with float. As you can see here, this E here. So E means 10 power and the exponent is 2 here. So 10 power 2. 3 into 10 power 2. A equals to 3 into 10 power 2. So you know, right, 10 power 2 is 100. So 3 into 100 is 300 and zero point 0. Because this is saved as a float value and not int value, we'll have 300.0. And this is E minus 2. That is 10 power minus 2. 43 into 10 power minus 2. So I'll just type it. So this 43 E minus 2 means 43 into 10 to the power of minus 2. So when I run it, A will have 43 into 10 power minus 2 value. And if I print it, as you can see, 10 power minus 2 will be 0.43, right? So we got that float value. So the class will be float only. And here you can see we have too many zeros again, and then we have 4. But if you see, we have too many zeros, right? At the end, this will be considered as zeros only. But as we have some digit, instead of only zeros, we have some digit like 2 or 4. That will be in exponents. So we have, after the point, we have 44 digits. So it is e power of minus 44. So if I run it, I'll get this exponent, the scientific notation, and that is still a float value. Now let's learn about Boolean values. So Boolean value is one of the predefined classes and it is treated as fundamental data type. So the purpose of Boolean value is to store true or false values. So that is the logical values. So internally, the values of true will be considered as 1 by the Python. So true means 1 and false means 0. So purpose of Boolean function, same like int function and float function, that is bool in parenthesis. So these functions are used to convert value into true or false values. So the syntax is bool, inside of that will give your value. Now let's move on to the coding part. So the purpose of Boolean data type is to store true or false logical values. So false means, so firstly true. Let's take true. True means any non-zero number or any non-empty strings. If your string value is at least a space and not empty, that is still considered as a true value. And if you have non-empty collections, that is still considered a true value. Okay. And when it comes to the false values, if you have 0 or 0 0.0 or some empty string like this, here true means even if you have a small space between your apostrophes, that is still considered as a true value. But if you have empty strings, that is considered as a false value. And if you have none value, that is also a false value. And if you have an empty list or set or dictionary, don't worry, you'll learn this in the next class. So these empty lists or sets or or dictionaries, these are all considered as false. Let's try coding. So A equals to true here. So print A. So we'll be getting the value true. And the type of A is class Boolean. And I've stored B equal to false. And B, if you print, it will be false. And the class of it will be bool or the Boolean type, right? So the class will be bool. So as I've said, internally true is considered as 1 and false is considered as 0, right? So if I try doing it, A plus B, so in A variable we have true and B variable we have false. So if I try printing A plus B, that will be 1. So A is 1, right? And B is 0. So 1 plus 0 will be 1. So that is the value you got here. So let's try printing true plus true. So what do you think you will get the value? True means 1 and another true, it is also 1. 1 plus 1 will be 2. So that way internally true will be considered as 1 and the false will be considered as 0. So if I try doing true plus false, that will be 1 plus 0, that is 1, and true means 1 and false means 0. So 1 into 0 will be 0 only, right? So I'll get 0. And if I try doing adding these Boolean values with some binary data here. So this is the binary value of 15, right? In decimal, if you convert 1111, you'll be getting 15. So false means 0. So 0 plus 15 will still be 15. And if you try 2 into false, that is 0. 2 into 0 is here 2 into 0. 2 into 0 is 0 plus true means 1. So 2 into 0, 0 plus 1, that will still be 1. So that is the value I got here. Now let us know about the complex data type. So complex is one of the predefined class and it is treated as fundamental data type. So this complex is used to store complex values. So complex values means the values which have real part and also imaginary part. So the general format of complex data type is A plus Bj or A minus Bj. So here A is your real part and B is your imaginary part. And here J, it is square root of minus 1. So basically in maths, if you learn, it will be written as A plus IB, right? So when you have some complex number, that will be written as A plus IB. So in place of I, you will just have J here and you should write that J after your imaginary part. So in that way only it will be valid. If you write like this, in place of I, you will write like A plus JB or IB, that will not be valid. You should only write as A plus BJ or A minus BJ. Okay, so A is the real part and B is the imaginary part and J is the square root of minus 1. So J is square root of minus 1. So to extract only the real part, that is the A, you can use a predefined attribute like I can give A equals to 2 plus 3J. So I want only the real part from that values. So I should do A dot real and then I'll get the real part. So the variable name dot real, if I give and print it, I'll get the real part of the complex number. And then B if we want imaginary part only, then we can give the variable name dot imag, imaginary. So we'll get the imaginary part of it. So we'll get 3. Internally, real and imaginary parts are treated as float values only. They are not int values, they are float values. So if we try, let's try the coding part. So complex values. So here you can see the example I've told. I have taken a equals to 3j. And I'll assign this. So a is assigned with 2 plus 3j. And if I want to print a, that will be printed as 2 plus 3j only. And the class is complex. Here I have some float values in the real and imaginary part, 2.3 and 4.6. And if I print it, 2.3 plus 4.6j will be printed. And the class is complex. And then 2 minus 3j. So this is the form of a minus bj, right? So that will be printed as 2 minus 3j and the class is obviously complex. And we can also have it in the form of 2 minus 2.5 minus 3.5j. So the real part and imaginary part both are negatives and it will be printed as this. And then moving on, I've told you the example, right? Imaginary, you should not mention I or any other letters for the imaginary part. You should be giving J only in this way. And if you give J before the imaginary part also, that will be not defined. So you'll get the name error. So you should be giving us 3J only, like the imaginary and then J. So now I want the real part of the variable A. So here I should do A point or dot A dot real. So A dot real is 2.0. As I've said, these values are internally float values. So we got 2.0. And then imaginary part, if I want only the imaginary part, I'll give the variable name dot image. And then imaginary part is 3.0. And then in the B, 2.3 and 4.5, the real part is 2.3. So we'll give B dot real. So we'll get the real part, which is 2.3. As it is also float value, it is given as float value only. And I want to print P dot imaginary part, that is imag. So I'll get the imaginary part. Directly also we can do it instead of saving it into some variable. What I can do is I can give the complex number here and dot real I can do. So that I'll get the real part in a float format. And then if I want imaginary part, I can use dot imag and get the imaginary part. So lastly, the practice problems. Today we are performing basic operations using addition, subtraction on different data types. So here you can see a equals to 10. So that is an integer value. I can perform operations like addition. So I can just print a equal to a plus 5 and the value will be getting as 15. And b is a float value. It is 3.5. Let's try it in the okay. Let's try it in our spider environment. So a equals to 10. So this is the int value. So I want to perform some. So I want to perform some addition on this. So a plus 5. So if I print a plus 5, when a equals to 10, I can perform basic operations like addition and I also perform operations like subtraction and also multiplication using the asterisk symbol. So 10 into 5 is 50 and I can just give some float value for a, let's say 13.4. On this also I can perform the basic operations. So I have multiplied this. So that is the value of 40.2. And then I can also give a equals to some complex number like 4 plus 3j. And if I print a also, I'll be getting the complex value. So that's it for today, guys. If you have any questions, please keep it in the chat box and that will be answered. If you like the videos, please subscribe to our channel and like the videos and hit the like symbol. Thank you, guys. That's it for today.